In this section, we're going to focus on a process called expanding, and what that means with polynomials, or in this case, algebra expressions. If you're familiar with distributive property, you'll recall that you share a single multiplier value, like x or 3, with the terms inside the brackets. The terms in this case are x and 1. Expanding is pretty much the same thing, but this time you are sharing more than one multiplier value outside the brackets. Instead, the values you are sharing are terms that make up their own expression. Think of distributive property as a younger sibling and expanding as the older one. Expanding is another exciting way to get rid of the brackets and write an algebraic expression differently. So let's take a look at the expression x plus 1 again. Instead of multiplying it by x or 3, we are going to multiply it by x plus 3. To expand, we now share the x and 3 terms with the x and 1 terms by multiplying and writing it out like this. So that's x times x to give us x squared. Then we have x times 1, which gives us x. Now that we have shared the x variable, we can move on and share the 3 constant. So that's 3 times x, which equals 3x. And now it's 3 times 1, which equals 3. Since the sharing is done, you take the terms that you've calculated and add them together. That gives us x squared plus x plus 3x plus 3. You now combine the like terms that are x and 3x and add them together to get 4x. And there you have it. We've expanded x plus 3 times x plus 1 to get x squared plus 4x plus 3. Let's try this again, but this time I'll make the x plus 3 x minus 3. When expanding, it's important that you add or subtract the terms correctly, and sometimes that can be a little tricky. We share the first x term again to get x times x, which is x squared. Then x times 1, which is x. In the case of 3, it is negative 3 because it has a minus sign in front of it. Therefore, when sharing it, we get negative 3 times x, which is negative 3x, and negative 3 times 1, which is negative 3. Like before, we add these terms together to get x squared plus x plus negative 3x plus negative 3. Since we're adding negatives, you could write it out like this instead. Now combine the like terms x and minus 3x to get minus 2x. Therefore, x minus 3 times x plus 1 expanded is x squared minus 2x minus 3. And that's how expanding works. What the heck. Let's expand this expression here, just for the fun of it. Again, the process is the same with all polynomials, no matter how large. So that's a times a squared to give a to the power of 3, a times 3a to give 3a squared, and a times negative 2 to give negative 2a. We've shared the a variable, now on to minus 2. That's minus 2 times a squared to give minus 2a squared. Next, it's minus 2 times 3a to give minus 6a. And lastly, it's minus 2 times minus 2 to give 4. Now we add all the terms together by combining like terms. 3a squared and negative 2a squared are like terms that we can add together to get 3a squared minus 2a squared, which is a squared. Also, minus 2a and minus 6a are like terms we can combine together. So that's minus 2a minus 6a to get minus 8a. Therefore, when expanded, the answer is a to the power of 3 plus a squared minus 8a plus 4. Now, some of you might be asking, how exactly does all of this make the expression more simple? Well, depending on the expression you're given, that might or might not be the case. However, it's a very useful skill to have, especially when you get complicated expressions or equations that require expanding. But there is good news. There are some pro tips or shortcuts to know to speed up the process of expanding. 1. Square of a binomial. When an expression with two added terms is squared, this ends up being the result. A plus b squared is equal to a squared plus 2ab plus b squared. So, as an example, let's expand a plus 2 squared. You could just expand the expression and multiply. That's perfectly fine. Or you can use the shortcut and plug the values in the expanded expression. So a is itself and b is 2. Therefore, a plus 2 squared is equal to a squared plus 2 times a times 2 plus 2 squared. Do the calculations and get an expanded answer of a squared plus 4a plus 4. Now let's look at what happens when a binomial being squared involves subtraction. The result ends up being this formula instead. That's a minus b squared is equal to a squared minus 2ab plus b squared. The main difference here from the previous formula is now the first plus sign is now a minus sign. So in this case, we will now expand a minus 2 squared and do the exact same thing by putting it into the formula. A minus 2 squared is equal to a squared minus 2 times a times 2 plus 2 squared. And therefore the answer is a squared minus 4a plus 4. Nice and easy with the simple change of sign. 2. Difference of squares. Another shortcut to remember is called difference of squares. This time the binomial or two-term expression is being multiplied with itself, with one expression having a plus sign and the other expression having a minus sign. When expanded, the formula looks like this: a squared minus b squared. So now, when we multiply a plus 2 times a minus 2 and simply put it into the expanded formula, we get a squared minus 2 squared. A squared remains as it is, and b squared, which is 2 squared, becomes 4. Therefore, the final answer is a squared minus 4. And that's how the basics of expanding works. Simply share the terms or use the shortcuts to get the job done to ace your test. Well, that's a wrap. Now get to studying.